So in 1953, an engineer named Cherry developed an experimental paradigm for looking at this question. And what Cherry did was a combination of two things. One is shadowing, the other is dichotic listening. So dichotic listening is shown here where you have two different messages going into the different ears. So we've got 4, 4, 4, some numbers being spoken into one ear, and in the other ear the person is listening to a story. And the way Cherry's experiment worked is subjects were supposed to attend to the ear that had the story, and they'd just be hearing some person reading some book, and so that's being read, and they're supposed to ignore the other ear. So dichotic listening is the information coming into both ears. Now, to really get subjects to focus in on the ear with the story, what Cherry did was had them shadow that story. So what that means is every word that the person hears in that ear, they're supposed to repeat out loud as it happens. So the person is hearing, she put her glass aside and got up, and at the same time it's supposed to be saying, she put her glass aside and got up. But the subject doesn't have that written out. They have to listen to the words and then speak them back while listening to the next words and speaking them back. It's a very, very difficult thing to do. And so while they're doing that, they're really focused in on that ear. And then the question is, how much are they able to perceive of the information coming into the other ear? And what Cherry found was they didn't seem to perceive much about the other ear. So the way this experiment would work is they're shadowing one ear, and at the end of 10 minutes of that, they would ask the person, well, what did you hear in the other ear? And people are usually able to say, yeah, I heard something in the other ear, it was a voice, and they might be able to tell you if it was a male voice or a female voice, but they're unable to tell you anything about the content of what happened in that other ear in most conditions. So even if you repeated the same digit many, many times, 4, 4, 4, 4, the person's unlikely to be able to remember that at the end and be able to tell you. So from results like these, the very first theory of selective attention was born. And this is a theory developed by a guy named Broadbent in England. And he proposed that attention operates as a peripheral gate. So what I mean by that, well, here, this is a picture of the brain systems involved in hearing. So here we have the cochlea, which is the inner part of your ear where sound is transduced into electrical energy, and then that information goes into the brainstem and up through the inferior colliculus and then ultimately up into the cerebral cortex. And Broadbent's idea is that if you're listening to one ear and trying to filter out the other ear, that at a very early stage of processing, where this X is, you're sort of blocking out the signal from the unattended ear. So if you're listening to this ear, this other ear just gets completely suppressed. So that's the peripheral gate theory. And it turned out very quickly that this theory was wrong. So subsequent research showed that you get a significant amount of information into the brain from the unattended ear. So the first evidence that in fact Broadbent was wrong came only 1 year later. Can you imagine that? 1 year after you publish your theory, somebody shows that you're wrong? So in 1959, Neville Morey published a study where he took the basic shadowing paradigm that had been developed by Cherry, and he added one twist to it. So in the information that was in the unattended ear, so subjects are attending to this speech stream over here and repeating everything back, and in the other ear, sometimes they would hear a name, like Emily Wong. And it was set up so that sometimes a subject would hear their own name, and other times it would be some other random person that they didn't know. And what Morey discovered was that people were able to detect their own name. They heard their own name and were able to report it back later, even though they couldn't detect other people's names. And what Morey concluded from this is that information is really fully perceived in the unattended ear, perceived to the point where you can tell something is your name or somebody else's name. And then if it is something that the brain determines is relevant, then it gets pushed up into awareness and gets stored in memory and that sort of thing. So if it's not relevant, it gets kept out of awareness, but if it is relevant, it comes in. So according to this idea, everything is perceived, but things are then blocked out before they get to awareness if they're not being attended.